Hello students, today let's discuss about the Turing machines. This machine is named as Turing machine because it was founded by Alan Turing. So this machine is named after him. Let's see how this works. The Turing machine model, it is a finite automation connected to read-write head with the following components. It is having three components. One is a tape, a read-write head and a control unit. If you remember the tape recorder tape, you will be having an audio tape, right? So that is the tape and you will have a read-write head, then you will have a finite state control. That you can just think of it. This is the tape. That on the tape, these are all the blank characters. This is some data which I have written, some AA, BB. And this is the read-write head and this is the finite state control. So there are three components: tape, read-write head and the finite state control. This is the Turing machine model. As and when we read an input, we replace by some other character just to note that that input is read. So before the start of the input, we will have all blank characters, infinite number of blank characters. After the input also, we will have all the blank characters. Now, the definition of the Turing machine. This Turing machine is also a 7-tuple Q sigma tau delta Q naught B A. I repeat, Q sigma tau delta Q naught B A, where Q is set of finite states, sigma is set of input alphabets, tau is set of tape symbols, delta is the transition function from Q cross tau to Q cross sigma cross left comma right. It is indicated as L comma R. Q naught is the start state and B is a special symbol. It indicates the blank character. A or F, which is a subset of Q, it is the set of finite states. So, a standard Turing machine, it has the following features. So, the TM has a tape, it is divided into cells. Each cell is capable of storing one symbol. The tape is unbounded with any number of left or right moves. It means the read-write head, it can move either to the left or to the right, one character at a time, or it can read one symbol at a time, but it can either move left or it can move right. The machine is deterministic and it can have either 0 or 1 transition for each of the configuration. And some symbols on tape, they are considered as the input. Whenever the TM halts, the symbol on tape are considered to be the output. And let's see the instantaneous description and the move in a Turing machine. Coming to ID, instantaneous description. An ID of Turing machine, it is a string in alpha q beta, where q is the current state, alpha beta is the string made from the tape symbols denoted by tau. That is, alpha beta belongs to tau star. The read-write head points to the first character of the substring beta. The initial ID is denoted by Q alpha beta. It means if alpha beta is the string, Q is the current state. So Q is the start state and read-write head points to the first symbol of alpha from left. The final ID is denoted by alpha beta q blank, where q belongs to caps A is the final state and read write head points to the blank character denoted by B. Okay. And how do we define the move for the TM, that is the Turing machine? Let M equals Q sigma tau delta Q naught A be a Turing machine. Let the ID of M be A1, A2, A3, AK minus 1, Q, AK plus 1, so on up to AN. So this is the state, Q is the state where AJ belongs to tau for 1 less than or equal to J less than or equal to N. Q belongs to, Q is the current state and AK is the next symbol to be scanned. So this is the current state, this is the next symbol to be scanned and this is the already scanned input. If there is a transition, delta of Q comma AK equal to P comma B comma R. So the move of the machine is A1, A2, so on up to AK minus 1, Q, AK plus 1, so on up to AN. This is the symbol for move. So when there is a move, this is the transition. When you are in state Q, on reading the input AK, change the state to P. The input would be B, move to the right. So AK is replaced by B, move to right. So how do we do this? We are in state Q and we are reading AK. So before this we have AK minus 1, Q should be changed to P and AK will become B. So till AK minus 1 you are moving, the head will go to right. So the head is here, it will go to right. So head should come after AK, but AK has become B. So AK minus 1, A1, A2, so on up to AK minus 1. Then AK has become B, Q has become P, AK plus 1 to AN. That is how the move works. Now, if there is a transition, delta of Q comma AK equal to P comma B comma left. So the previous case we moved the head to right. Now we have to move the head to left. There is a change of state. State Q will be changed to state P. Input AK will be replaced by input B. The head should be moved to left. So we will see how to make this move. Then the move of the machine M will be, see this is the present configuration, A1, A2, so on up to AK minus 1, Q, AK plus 1, so on up to AN. Now we have to make a move. When we have to make a move, this Q should be changed by P, AK should be replaced by B. Q should be changed to P, AK to be replaced by B and the head should come left. So head will come here. So head will come here. So what is here? AK minus 2. So A1, A2, so on up to AK minus 2. After AK minus 2, head comes. Q has become P. Now we have AK minus 1. Then this has become B. Correct. So B, AK plus 1, so on up to AN. So that is how the move works. Now let's see how to accept a language. Acceptance of a language by the TM. So let M equals Q sigma tau delta Q naught be a Turing machine. The language L of M accepted by M is defined as L of M equals set of all W for all Q naught on W in one or more moves is alpha comma alpha 1 P alpha 2, where W belongs to sigma star, P belongs to A, and alpha 1 comma alpha 2 belongs to tau star. This is how we write the acceptance of a language by TM. That is, set of all those words W in sigma star which causes M to move from start state Q naught to the final state P. The language accepted by TM is called recursively enumerable language, or the RE language. So, how do we define this recursively enumerable language? A language L is recursively enumerable if it is accepted by a TM. That is, given a string W which is input to TM, the machine halts and outputs yes if it belongs to the language. If W does not belong to the language L, the TM halts and outputs no or runs forever. That is, it runs into infinite loop. Such language is called decidable languages. So that is about the introduction of Turing machine. Thank you.